one photo in different sizes. Dilations. Dilation is where a two-dimensional shape grows or shrinks proportionally from a point called the center of dilation. Here we tripled the original rectangle, and here we divided it in half. In dilations, the dimensions and distances from the center of dilation stay in proportion. The center of dilation can be anywhere in, on, or outside of the shape. Scale factor determines how a shape grows or shrinks. If the scale factor is 3, the dimensions from the center of dilation are multiplied by 3. Different sizes, same proportions, same shape. A coordinate grid can help us see how this works. If the center of dilation is 0, 0, and the scale factor is 3, the horizontal distance from the center of dilation is 3, and the vertical distance is 4. Multiplied by a scale factor of 3, the horizontal difference becomes 9, and the vertical distance becomes 12, stretching the shape 9 units to the right of the center of dilation and 12 units up. Nice portrait, Kate. Grandma and Grandpa are so proud. If the scale factor is 1/2, the original dimensions are multiplied by 1/2. The dimensions of the reduced photo are 1.5 and 2. Different sizes, same proportions, with dilations.
Okay, so that was something that is pretty basic for us to understand, I believe. When I multiply, it's going to get bigger. When I multiply by a number bigger than 1, it's going to get bigger. When I multiply by a number smaller than 1, aka a fraction, I'm actually going to divide by the number that's on the bottom, and that's going to make my dilation smaller. So if you have your sheet in front of you, you should be able to look and see that it says the blank or blank of a figure, and that should be the reduction or enlargement of a figure. So I can make it smaller, I can make it bigger. The next blank says the blank blank indicates how much a figure will enlarge or reduce. And he talked about that. That was called the scale factor. That is the number that I'm going to multiply by if it's bigger than 1, or I'm going to take and divide by the number on the bottom if it's smaller than 1, which will make my, my picture bigger or smaller. If it is equal to 1, and this is not something you have to write down, if it's equal to 1, then the size doesn't change because I multiply by 1. The variable for a scale factor is called k, so you can just write the letter k there. When k is bigger than 1, so you can say k greater than 1 right here. The dilation is an enlargement. Enlargement means bigger, right? When k is less than 1, the dilation is a reduction. Now I forgot my document camera at school. I don't have it because I'm out sick. But you can see that since all I'm doing is multiplying by the number, right? This number k is 2. I'll take it and multiply by all of these. So r, -5, 1. I'd multiply. My new value would be -10, 2. 2 times 5 is negative, or 2 times -5 is -10. And 2 times 1 is 2. We could do s as well. 2 times -3 is -6. 2 times 4 is 8. Right? And finally, I could go over here. 2 times 2 is 4. -1 times 2 is 2. And then this is just like all the other papers you've had where you need to graph. But it's much easier to go ahead and do the multiplication and then graph in this case, like it was with translations. Down here, right, this is one where the number is less than 1. So I'm going to divide, right? So -10 divided by 2, because that's my denominator, gives me 5, or -5 in this case, because that was negative, right? 2 divided by 2 is 1. And I will write out that multiplication so you can see it next class, but now you can think of it as a division problem. A fraction is always telling me to divide something. Negative 2 divided by 2 would give me negative 1. 8 divided by 2 would give me 4, right? So this is what y'all are doing on this paper. At the last couple of pages, or problems, not pages, you're going to be doing that for all of these. On 7 and 8, you're going to have to pull out the numbers and you're going to have to divide yourself. So I would have to see what 8 was. It looks like it appears to be negative 2, 8, right? 1, 2, and then up 8. And then I'm going to divide both those numbers by 4, right? So it's exactly what I was doing on the first ones, but now I have to pull the number out myself. And then right here, I'm going to graph the image of the quadrilateral using the scale factor below. So I'm going to take these, and these are a little bit harder because I've got a number on top and a number on bottom, right? So I need to multiply by the numerator on top and divide by the denominator. Denominator means divide. Okay, so for example, I've got r right here, and it is at 1, 2. So I'd multiply by the number on top, my x value, and I'm right here. My x value would multiply by 3. So 1 times 3 is 3, and divide by 2. So it's actually 3/2. And I've told y'all a couple times, I don't expect you to use the division there. I am fine with you leaving it as a fraction. And then we will do the y value. That is 2. 2 times 6 is 6, or 2 times 3 is 6. Divided by 2 is 3. So my answer for the y value would be 3. You're going to do that for all of them. And finally, 11 and 12. I'm going to look at these, and I'm going to say my initial d value, remember this is the initial because it does not have a prime beside it. My initial d was 0 in my x because it didn't move off the axis. 1, 2, 3, 4, 5, 6. My new one is 1, 2. What did I divide that by to get 2? 6 divided by 2 is 3, so my k would be 3. And we should be able to check. It should be the same for all the points. This was 6. Or sorry, this won't be 3. If I divide by 3, I have 1 over 3, right? It got smaller. Over here, it should be a number bigger than it because it got bigger. It went from here to here. This one went from here to here. Hopefully that's enough to get y'all through today. I apologize for being out, but we will definitely go over this a little bit more next time. Make sure that you give this to Mr. Nation before you leave, or you can leave it in the drawer, and I will get it out of there tomorrow. Okay? Have a good day.